Hello and welcome to this episode of Microchips. In this episode we're looking at a Uniden UniAce 200 that I bought, and it shouldn't be faulty, so we're going to try and put a mid-band modification on it. So here we have our Uniden UniAce 200. It's a little bit dirty, but nothing that can't be sorted out. This should be in fully working condition because it was bought as working. So today we're going to try and fit mid-band to it. And there's inside, everything looks good, everything looks like it's not been tampered with. It's nice and clean, as you would expect for a Uniden. Now, first part of the modification, we need to connect the collector of TR17, which is there, and we need to connect this to the junction of R33 and D6. This supposedly is going to fool our VCO into locking on the lower frequencies. And that's all we need, just one piece of wire going across the board. Now, I've been reading there are some modifications out there that require capacitor changes, but we'll just do this and we'll see if we need to broadband the VCO. So first things first, out with the PLL chip. So there's our PLL chips. Now I hear you say, oh, you just piggyback them. Just cut a few wires, join a few wires. Well, if you've seen my videos before, we don't just do piggybacks. We try and make them look a little bit better. So I've had a few boards made, and we're going to try them out in this radio. Now I hear you say, how are you going to get this to fit in there? Because there's no way that's going to fit anywhere inside there. Well, it just so happens that we have a solution that hopefully is going to work. We have these extra long pin headers that I bought from China. So hopefully that'll give us enough clearance to mount this. First things first, let's put our band select wires in. And there. Now even though these were the longest pin headers I could find, they're still just a tiny bit short. And there's the two PLL chips soldered in place. Hopefully with this configuration this should just give us enough clearance. And there it is installed, and yep, we do have plenty of clearance, and that should be quite sturdy as well. Let's fire it up and see what happens. So something's actually happening. Oh, this should be ukfm. So everything seems to be working on ukfm. Now let's try mid-band. Now I've not got this connected to a switch yet, we're just using wires. So we are receiving. And nothing's happening right down at the bottom end. So looks like we need to do some VCO adjustment. Just looks like it's right down the bottom end. So hopefully just a little nudge of the VCO and we should get this. Something strange was happening there because I was actually on channel 3 on another radio, but on this one it was showing 2. but I think just a little VCO adjustment should be good. Okay, so that was channel 40 ukfm. This was after a VCO adjustment 6012 or 6013, so that's pretty much bang on. And I think we're having our VCO problems there. There we go, 26966, 27406. So that's a bit high, but hopefully we've got a solution to fix that. Now we're just going to try and equalize the power output stage. So with my scope probe on the collector of the pre-driver, very similar to how you do it on a Cybernet chassis. We're just going to peak the coils, just make sure that that is tuned correctly. Everything looks good. It doesn't look too far out at all. So I think we should be good with that. Just checking high and low power as well. I don't think we can get those anymore. Just going between channels 1 and 40 as well. Kind of got it level-ish. Now we're on the final output now. I don't think we need to mess about with the PA stage any further. So we're going to use the tone high and low for high and low. And there's it connected. We've also connected a connection for 13 volts as well, and you'll see why soon. So ukfm is bang on, and mid-band is running slightly high. Now I know you're thinking, well, that's not too big of a deal. Hopefully we've got something that'll fix that. So yeah, mid-band slightly high. Now, as per the Midnight Express 2 book, this is a little frequency compensation circuit. And there it is built. Now I'll put a variable capacitor on it, thinking I'll be able to trim the frequency using that. But that kind of didn't work out how I'd planned it, but we'll see. So that's where this little board's going to live. It just sits nicely there. Once we've settled on the frequency, we'll put it in its heat shrink tubing. Now I did do a lot of messing about now. A lot of it I did off camera because I actually found out that using the variable capacitor wasn't the best of ideas. It did trim a little bit, but it didn't trim as much as I'd like it to. It did move it ever so slightly. Now the circuit says we should switch in 12 picofarads, and this is a 20 picofarad variable capacitor, which I thought would do the job, but it only seems to bring it down ever so slightly. So I started changing the values of the variable capacitor. It actually went down to 10 picofarad, and that didn't make any difference. And then we moved all the way up to 100 picofarad, which seemed to be the sweet spot. But we'll just carry on with this, because you can see I'm trying to bring in mid-band. And we're getting mid-band very, very, very close. So the trimmer does do something, but it just doesn't move it enough. Oh, I haven't got a non-inductive trimmer that small to go in there, so that's why I'm having to adjust it and then transmit with the screwdriver not in there. As you can see, with a little bit of fine adjustment, we get 405, which is nice. 965, bang on. Now the problem now is when we move to ukfm. ukfm is now low, which we didn't want. So this was just moving the white wire between the two legs of the crystal. So in the end, I moved up to 100 picofarad variable capacitor, and it put mid-band absolutely bang on. So I thought, I know, let's try and just put a standard 100 picofarad capacitor in place of the variable capacitor, and sure enough, it's near enough bang on. As you can see, ukfm is bang on, 6012. So happy with that. Now we'll do some receive tests. Use my other radio as well. So we're receiving good. So this should be on mid-band because the switch is out for low. So using my realistic, just going to check sensitivity. Everything seems to be working nicely. So as I was messing about, I did notice that the front fascia was loose. And sure enough, we take all the knobs off and the front fascia just falls off. So whilst it's off, give it a nice clean. I'm not going to try and get rid of that glue on the back. And of course, we'll give the control knobs a good clean as well whilst we're at it. And a liberal helping of B7000 glue. And then we'll place the front back down. Make sure it's pushed firmly into place. And we'll rotate all the knobs in one direction so we can put them back on. Now the bottoms had a nice clean and a screw fitted into the speaker. And we'll just have one last look at the modification before we seal it up. So I think it's turned out quite nice. I know we could have just piggybacked it, but that's not what this channel's about. I actually think that's quite a nice modification. It's quite tidy, and I think it's quite unique. And with the frequency compensation in there as well, this radio should be pretty much bang on. So final test. And it's receiving correctly. Not much happening this time of night because I actually did this quite late. So there we have it, a Uniden Uni-Ace 200 converted to mid-band, or should we say dual band, UK and mid-band. I think the process went quite smooth. Very happy with my boards, very happy with the way it turned out, and it looks nice and neat. So anyway, I hope you enjoyed this video. If you did, don't forget to like, subscribe if I've earned your subscription today. Thank you very much, and we'll see you in the next video.